our one of our There we go. The recording has started. So welcome to our Tribal Community Resilience webinar series. My name is Allie Scott. I am one of our Tribal Resilience liaisons in the Midwest region, and really excited to be assisting to put on this webinar series today. Also working with Yvette Wiley, who's another one of the Tribal liaisons in our network. And we're excited for you all to be here today. So we wanted to get started with just a few short announcements before we jump into our presentations. We just wanted to note that for our webinar today, we will not be allowing any AI or note-taking bots into the room. They will not be permitted and we will remove them. We're going to ask that you all remain muted with your camera off during the presentations. You can unmute and turn on your camera when we go into Q&A, which will be later in the session. So please hang on to your questions. Feel free to put those in the chat as we go. And we'll answer those at the end. The presentations are going to be recorded today and they will be available for later viewing. So we'll be really grateful to our partners at the Southwest Cask for helping us with that. We will not record the Q&A and discussion portion. Please do submit questions for speakers at any time. I don't believe we have the Q&A feature enabled, but you can put those in the chat and we will get to those at the end. And then just a note here that the views expressed by our speakers today do not necessarily represent those of the hosts or affiliated organizations, but we are really excited to have a great conversation with everyone today. So we wanted to give you a little bit of background about the webinar series, which is being hosted by the Tribal Community Resilience Technical Assistance Providers. So the regional TCR, Technical Assistance Providers, connect tribal nations, villages, and pueblos to resources, funding, and to other opportunities all throughout the United States. And you can reach out to us at any time for technical assistance with adaptation and resilience training, planning, funding, and other things that you might be working on. We are available to help at any stage of an environmental project related to adaptation and resilience, including brainstorming what types of projects might make sense for your community or nation. For example, we help with vulnerability assessments, adaptation plans, and relevant grant applications, and provide trainings for tribal technical staff. And if your regional technical assistance provider doesn't have the expertise that's needed to support some part of your work, we can connect you to someone who does. We leverage a really wide network of partners, including federal agencies, state agencies, universities, and tribal organizations and tribal nations who all work together. And so we're really happy to be able to connect you in that way. So we're going to put links in the chat shortly where you can reach out to us for support at any time. I just wanted to highlight that as a resource that's available to you. And we also wanted to note that registration for this series is ongoing. So we invite you to register for all the sessions. And if you haven't already, to share this series with your colleagues. So we hope that you'll join us for next month's session, which is about emergency preparedness. And we'll also put the registration link in the chat in case you need to have that again. And so without further ado, I'm going to shift us into today's topic, which is fish and wildlife, with a focus on range shifts. And to get us started, I'm going to give a brief background on this topic so that we're all on the same page before we go into discussion. And so, what I think is really important when we start out is recognizing that wildlife and fish around the world are already responding to the impacts of climate change. And there's some really common examples that we're seeing happen with this, with fish and wildlife. One of these is changing phenology. So, this is the timing of life cycle events in plants and animals, such as breeding and migration. And a really common example is that many songbird species are starting to breed earlier in the spring. There's also species that are starting to change their behavior. And so I think this is a really cute photo of an American pika that's in a cold environment in the top photo and has puffed up its coat and held its limbs in to try to stay warm. And in the bottom photo, it has stretched out to try to shed that excess heat. This is an example of behavioral thermoregulation. And so there are species that are spending different amounts of time engaging in those types of behaviors to try to cope with a changing climate. We're also starting to see some species that are actually changing their morphology. And so physically, physiologically, they're starting to exhibit changes in their bodies to cope with changing temperatures. And a really common example of this is they're starting to have, on average, smaller body sizes and longer appendages that help them shed that excess heat. And then finally, the response that we're going to focus the rest of our session on today is range shifts, and this idea that wildlife and fish are actually adjusting where they exist in space to better track those optimal conditions as they shift. And so we wanted to highlight just a little bit more about understanding fish and wildlife ranges. If you're not familiar with this term, a range is the geographical area where a species occurs. This is where you can find them. You can find maps, such as the one on the right of this slide, that show where a species is located. And these, even though we draw them on a map and they have these nice crisp lines that we draw, they can actually shift over time. And this can happen in response to changes in resource availability, so things like food, water, shelter, and space. It can also be changing environmental conditions, especially things like temperature and moisture levels. And these can shift in response to relationships and interactions with other beings who live nearby. And so when we're thinking about range shifts and how they play out across the landscape, there's many different drivers that can play a role in how these play out. This can be things like human land use change, species invasions, disease, natural disturbances, and climate change. And what's really important is that all of these drivers can interact with each other and exacerbate each other. And climate change in particular can be known as a threat multiplier that changes the way all these different things play out, and is really important to pay attention to when we're trying to anticipate and plan for wildlife range shifts. So, throughout the globe, many different species are shifting their ranges. They're shifting poleward, they're shifting upward in elevation, or for aquatic species, that sometimes looks like going deeper in depth. What's really important is that different species shift at different rates. They have different tolerances, different needs, so they're not all moving across the landscape together as intact units. And instead, this means that familiar assemblages of plants and animals are actually getting separated as they're responding differently to the pressures that are driving potential range shifts. When we think about tribal nations, there's a lot of different important implications for indigenous communities related to fish and wildlife range shifts. And more broadly, I think an important one is that today's political boundaries and jurisdictions mean that indigenous territories and treaty rights are fixed in place, even when fish and wildlife relatives are shifting their ranges outside of those territories. And so this can actually result in the separation of communities from their non-human relatives. So that's a little bit of a primer on this topic. We are really excited to have three wonderful speakers with us here today to talk more about this issue and the ways that tribal nations and organizations and their allies are responding and what this looks like in their communities. And so I'm going to hand things over to Yvette, who's going to introduce our speakers and kick things off.
Okay. I let me know if I got this out of order, but I have Morgan Swingen going first. Is that correct?
Yep.
Okay. All right. I'd like to introduce Morgan Swingen. She is a wildlife biologist with the 1854 Treaty Authority. And where are you working out of, Morgan?
I work out of Duluth, Minnesota.
Oh, I like Duluth. Okay. All right. Well, I'm not going to take we have short amount of time here, so I'm going to kick it off and let you go.
Okay, let me get my screen situated here. I think I've got that going. Okay, can you all see my presentation? Great. Okay. So yeah, I'll get going. So my name is Morgan Swingen. I'm the wildlife biologist, as I said, at the 1854 Treaty Authority. And 1854 is an agency, so we're an intertribal natural resources agency, and we're governed by two tribes, the Grand Portage Band of Lake Superior, Chippewa, and the Bois Forte Band of Chippewa in northern Minnesota. And we work to protect and implement treaty rights to hunt, fish, and gather off reservation in lands that were ceded to the U.S. government in the Treaty of 1854. So that's called the 1854 ceded territory. And this is located in what is now northeastern Minnesota. It covers over 5 million acres, including nearly 3,000 lakes and over 150 miles of shoreline on Gitchigami or Lake Superior. So just to step back a second first to think about ecosystems, this map shows 15 kind of broadly categorized ecosystems or ecoregions across Canada, the US, and Mexico, from tundra and taiga in the north to deserts and tropical forests in the south. And generally, all of these ecosystem types are driven by gradients in temperature and rainfall across the continent. And if you can see now that little black outline in the middle, that's the 1854 ceded territory. And it lies in an interesting area ecologically. So we're near the edge or kind of at a transition zone between northern or boreal type forest and temperate deciduous forests. And the different tree species composition between the forest types is mainly driven by the cold tolerance of those species. So like the coldest winter temperatures that they can withstand. And being near this edge means that many of the wildlife species associated with these habitats are near the edge of their geographic ranges in and around the 1854 ceded territory. Like many areas in our region, we've seen increasing average annual temperatures. The most significant warming for us has occurred during the winter, over 5 degrees increase in average annual winter temperatures. And accordingly, we have a longer frost-free season, which translates into a longer snow-free season and ice-free season on our lakes. We've also seen increasing precipitation in our area, particularly in the fall, and we've had more frequent heavy precipitation events. So looking into the future under various climate projections, we expect we'll continue to see these temperatures rising and to see more precipitation with more variability, meaning more frequent heavy rain and snow events, but also periods of drought. And these changes are affecting our environments, our plant communities, and the wildlife that inhabit them. So because wildlife ranges are tied to habitat often, and where we are near the edge of this, the edge between two different habitat types, we see many species that are at or near the edge of their range. Some of those species are at the northern edge of their range, so they're moving north into or further into the 1854 ceded territory. These include species such as wild turkeys. As recently as 2013, when this map was created, turkeys had not been recorded as breeding north of Duluth, where I am. But in the last 10 years, we've seen a lot more occurrences of turkey broods much farther north into the ceded territory. Another example is flying squirrels. So in Minnesota, we have both northern and southern flying squirrels. And recent research by some of my colleagues over at the University of Minnesota Duluth have shown that both of their ranges have shifted northward in the state as well. So southern flying squirrels have sort of moved into the ceded territory, and northern flying squirrels are retreating northward. They're still in the ceded territory now. And then we also have species at the southern edge of their range shifting northward, which may eventually mean that they will shift out of the ceded territory. So snowshoe hare are a really great example. We don't have super detailed data in Minnesota, but in neighboring Wisconsin, some great research out of UW-Madison has documented a shift in snowshoe hare range, roughly 30 kilometers or so northward across the state. These shifts have mainly been linked to phenotypic mismatch. So that's when the snowshoe hares are remaining white in their winter coats when the snow is melting earlier, so they're not matching the background. And we have anecdotal information that similar range shifts have happened for snowshoe hares in Minnesota as well. Lastly, moose, which is kind of the focus of what I'm going to talk about today. So I've got a whole nother slide just to talk about them. But you can see in this map the primary area where we have most of our moose in the state of Minnesota is in the 1854 ceded territory. So for moose, I've got a different map here. So this is a map like looking straight down on the globe. Moose have a circumpolar distribution, it's called. So they exist at northern latitudes across North America, as well as Europe and Asia. And click here, my little blue triangle there at the bottom. That's showing where the 1854 ceded territory is in relation to moose range. You can see we're at the southern edge, as I was mentioning. And then this GIF that's playing now, this is illustrating how moose range in the state of Minnesota has shifted over time. These shifts are likely driven by a number of things, including climate, changes in habitat, but it is a complex system, of course. There are other factors that might have influenced this range change, including predators and parasites, which can also be influenced by climate, as Ali was talking about earlier. So moose can be affected both directly and indirectly by climate, by a warming climate. The most direct way is by heat stress. So since moose are at the southern edge of their range, that kind of indicates they're at the edge of their thermal niche where they can exist. Research done by some of my colleagues at the Minnesota DNR has indicated that moose in Minnesota are most likely to be heat stressed in the summer, which is not groundbreaking. But they found that moose are likely to be hot above a kind of threshold body temperature when the ambient temperature is 77 degrees Fahrenheit or warmer. And of course, those days are happening more often with climate change. And when moose are heat stressed, they kind of take breaks. They can cool off, go in the water, they can lay in the shade, they can reduce their activity, but that can reduce the amount of time that they could spend foraging. And that in turn can lead to lower body condition, lower reproductive success, a higher susceptibility predation, potentially. And then additional research has shown that the moose in their study that were heat stressed more often were actually more likely to die than moose that were heat stressed less often. In the long term, climate change will also cause changes in habitat. An important note here is that conifer tree species provide better thermal cover in more seasons than deciduous species do. And those conifer species, of course, are largely associated with the boreal forest and not the temperate forest further south. There are also many indirect effects of climate change on moose, which I won't go into detail on today, but they include increased overlap with white-tailed deer, which carry two parasites that have negative impacts to moose, brainworm and liver flukes. Shorter snow seasons caused by climate change also mean an increased survival of another parasite called the winter tick. And then there's also speculation that warming climates will lead to an increase of predators for moose, and in our area that is gray wolves and black bears. So recognizing that climate is impacting the 1854 ceded territory and the beings within it, our agency, in collaboration with the bands in the ceded territory, created a climate change vulnerability assessment and adaptation plan. This was originally published in 2016, and then it was updated just last year in 2025, and this is available on our website. And in this plan, of course, they did a vulnerability assessment of many of the beings in the ceded territory, and several of those species and groups are highlighted as focus beings. And for each focus being, a detailed list of strategies for adaptation was developed to address potential impacts from climate change. And moose were one of the focus species in the plan, and many of the strategies for moose focused on collaboration, research and monitoring, and habitat management. So I'll just very briefly share some of the work we are doing with moose here at our agency. We recently began a new project in collaboration with the state agency to monitor juvenile moose recruitment and survival. That just started this past winter. We also continue to be involved in monitoring efforts of the moose population through an annual aerial survey that we collaborate with the state and the Fond du Lac Band to complete. And in addition, we have a number of projects that are kind of monitoring some of the indirect factors related to climate and moose, including monitoring prevalence of parasites in white-tailed deer that can affect moose, monitoring snow depths across the ceded territory within moose range, conducting research and monitoring of predators, in this case wolves, And then lastly, we've also participated in many different efforts to improve habitat for moose, including creating and maintaining thermal cover across the landscape to mitigate heat stress. And that's all I've got time for. I've got my contact info up here if you want to learn more, but thanks to the organizers for inviting me today, and thanks everyone for tuning in. I will stick around for the Q&A session.
All right. Thank you, Morgan. I believe we're going to hold for questions until the very end. So I'm going to go ahead and jump right in and introduce Carolyn Brown, who is a Subsistence Resource Director with the Alaska Fish and Game. And I'm very excited about her topic. I'm glad she's going to be able to be here to talk about beavers, one of my favorite little animals. So take it away, Carolyn.
Thank you. Let me see if I can share my screen here. Maybe somebody can let me know when it shows up. Can you guys see it now? Yep, you can. Okay, great. Yeah, so thank you so much for the invitation to talk a little bit about beavers. They are also some of my favorite little critters. So I think a lot of us understand beavers to be ecosystem engineers, but they're also a really important subsistence species, and they have wide-ranging effects on ecosystem structure. So in Alaska, warming air temperatures associated with climate change have enhanced shrub vegetation growth and unfrozen water in the winter, thus improving beaver habitat and driving expansion from forest to tundra regions in Alaska. So the ABON, which is the Arctic Beaver Observing Network, is a group of community representatives and scientists, circumpolar scientists, and community representatives from all over the circumpolar north, who are looking at the effects of beaver engineering on freshwater and terrestrial ecosystems, including local resources like clean drinking water and access to fish. So as I mentioned, ABON is a group of circumpolar north scientists and residents, and that have been working together since about 2021. And in Alaska, we have about 11 beaver engineering sites in Northwest Alaska. And in addition to that, we've been working intensively with community members from 3 different villages in Northwest Alaska, which are Kotzebue, Shugnak, and Noatak. You can see them on the map there. And historically, beavers have been very present in the interior Alaska, but they're now moving into Northwest Alaska. And these 3 communities are really cool to working together on this project because they represent 3 different, even though they're all in Alaska, they represent 3 different experiences of beaver. So beaver have been present in Shugnak for about the last at least 50 years. Elders and residents there regularly hunt beaver and use beaver, and have lots of experience and generational knowledge of them. They've been in Kotzebue for about 20 years, and their Noatak is just on the edge of their range at this point. They're just starting to see them. And all 3 of these communities are primarily Inupiaq communities where subsistence is really quite critical. If I can.
Hey, Carolyn,
but first,
I
yeah.
interrupt you for just 1 second. I'm so sorry. I just want to make sure. I think your mic is kind of going in and out. Maybe just adjusting it slightly might help correct that. Sorry, just wanted to make sure.
Oh, sorry about that.
Hear all the wonderful information that you're sharing.
No problem. Thank you for that.
Absolutely.
And let me know if it continues. So first, just a little bit about the Division of Subsistence at the Alaska Department of Fish and Game. Our division was actually created by statute in 1978 when the state subsistence statute was passed. And our division's mission is to scientifically quantify, evaluate, and report information about customary and traditional uses of fish and wildlife resources because of their importance to Alaskans and specifically rural communities for food, but also for cultural importance and as a way of life. So at the Alaska Department of Fish and Game, we're a purely research division. We're also social scientists, not physical or biologists. And as a result, we're in a pretty unique position to study and understand the human dimensions of resource management. I included this quote about subsistence for those who are less familiar with the term, but this is from a Venati resident who is at Interior Alaska community closer to the border of Canada. And he says, when we speak of subsistence, we don't just mean using the resource, but using tribal methods and acting out culture and complying with those values. And we do those things because they're a measure of protection for the land and its resource. And for us, that's sort of foundational in the work that we do and the research that we do, that it really highlights the connections between people, the land, and the animals. And so that's a really critical part of understanding wildlife through that lens. So beavers really shape the landscape to an extent that is visible from space. Satellite images and aerial photography we've used to detect when beavers move into a stream and start building dams and creating ponds that are evident in the image on the left, which compares the same segment of river from 1980 to 2019. And then the second set of images is a very similar thing. If you see those white arrows in the 2016 block, those are all dams that were built. And so in a much shorter period of time and an accelerated pace, we see very similar things. So beavers have really transformed these relatively simple waterways into complex ponds and streams, and that dramatically changed the landscape for Northwest Arctic and for their residents and how they use the land. So a lot of the primary concerns expressed by residents are really how beaver dams and lodges act as impediments for fish passage between important habitats such as spawning and rearing. So a lot of those concerns centers around dams impeding fish migration up into spawning areas, trapping fish in beaver ponds, and also the water quality issues associated with beaver ponds and ponded water. In addition to animals, they affect humans too. Dams impede boat access to smaller sloughs that can affect the harvest of other subsistence resources, such as migratory birds in the fall and even trapping in the winter, because the changes to local hydrology through permafrost thaw change waterways and fishing locations. They can pose safety concerns because it changes the way that water bodies freeze and thaw, can create weak ice in certain places, especially around lodges. There's been a lot of studies in the more boreal areas of Alaska looking at beavers in temperate ecosystems, but ABON has actually quantified dramatic increases in the spatial extent of beaver ponds in the tree line and tundra areas of Alaska. So the graphic on the left there shows the beaver pond increases in Northwest Alaska from about 2003 to about 2017. Those shaded rectangle areas are the areas where we assessed issues and using overlapping high resolution satellite images. And so as climate change has affected or created more favorable habitat for beavers, the number of beaver ponds in this part of Alaska and Northwest Alaska has actually doubled since 2003. And underlying these landscape changes are other really important processes. So a new beaver pond forces groundwater downward
and over permafrost, increasing heat absorption and thawing permafrost, and leading to widening river channels that we saw in some of those other pictures and those ponding effects, with thermokarst formation surrounding these ponds. So these changes release stored carbon dioxide and methane into streams and into the atmosphere. And as a result, the dynamics of beaver pond disturbances is likely accelerating climate change and climate warming, especially in the Arctic. So what does the future look like? Well, we use environmental attributes like air temperature, vegetation, stream flow, things like that, of the habitat that beavers select to determine their habitat preferences. So in tundra areas, they choose areas with warmer air temperatures on average, lots of shrubby vegetation, they depend on wood, and with enough water in streams to supply the pond. These are not attributes that have been typically associated with the Arctic and tundra, but with climate change, they are more and more. So modeling these attributes into the future and using predictions of climate change and climate warming, beavers are continuing, we know they are continuing to expand their range. And in the case of Alaska, we expect that they will inhabit the North Slope and go over the tree line by about 2050. So that's not that far away. So we do expect the North Slope to be colonized, and that will bring further dramatic changes to the more northernmost reaches. So in terms of future work, we are continuing with annual ABON meetings, and these are really cool and exciting opportunities where scientists and local residents come together and share information and think about some of these feedback loops. We're working to connect communities with resources to address water quality concerns, especially as beavers move in and create dams and lodges right next to communities, which is definitely happening. We also are supporting the local desire to incorporate beavers into local subsistence economies, especially in some of these Northwest communities that have never seen beavers and don't use them, through the creation of knowledge sharing networks that these communities are engaged in. And then finally, improving resources to support local efforts to remove beaver structures that they are concerned are harming either their other resources or are impeding access to resources or access for resources like fish, especially. So that is what I have. I hope it was under 10 minutes.
Very good. Thank you, Carolyn. Now then, moving forward, I'm going to introduce Jane Breckinridge, who I feel like I know pretty well. We don't have time to go into all of the magnificent things that her and her team have built just down the road from me. So I'm going to let her do that, and then we'll open it up for questions when she's done. So Jane Breckinridge with the Tribal Alliance for Pollinators and the Euchee Butterfly Farm.
Okay, thank you. So I'm going to turn off my video while I give my presentation, just because my internet's not very stable. So, and then I'll come back as soon as it's done. So let's do screen sharing here. And here. 1 second, I'm slow on the tech. And there we go. Okay. Okay, can you see that okay? Yes, okay. Hopefully that's there. Okay, so thank you so much for inviting me to be here today. I'm Jane Breckinridge, and I'm the director of the Euchee Butterfly Farm and the Tribal Alliance for Pollinators. And today, I've been asked to speak about how different butterflies are being impacted by climate change and different stressors towards the migration and the range shift. So monarchs are something that we spend a lot of time doing work on, and because they're having a very hard time. So it's less of a classic range shift and more disruptions to the migration and different ways that we can build resilience to it. So monarch migration is one of the great, I know I'm biased because of what I do for a living, but it is one of the great natural phenomena in the world of wildlife. Every year, monarchs overwinter in Mexico and their overwintering grounds, and then in the spring they will go up north to Oklahoma or Texas. Hopefully they're lucky enough to find milkweed to lay their eggs on. It's the only host plant that their larval stage of their development can survive on. And then subsequent generations will push further north up until about June 10th, when they get into the northern upper Midwest and the southern part of Canada. And we don't really see any more northward movement after that time. And they will be there for the summer. And then starting about August 10th at the northern latitudes, once the angle of the sun at noon falls below 57 degrees, then they're going to start this reverse migration. They are going to fly up to 3,000 miles, and so it's really remarkable. So anywhere 1,000 to 5,000, 3,000 miles, and the really amazing thing about monarchs too is that their overwintering grounds in totality are less than 10 acres, and in a very remote area in Mexico. And yet all these butterflies, these hundreds of millions of them some years, are going to find this, and none of the monarchs in this migration have actually been there before. Their great grandparents left in the spring. So anyway, it's really, really amazing, and scientists still aren't sure exactly how they find it, but it is really an incredible phenomenon. So unfortunately, we're seeing, like with everything else, there are many stressors from climate change that are affecting directly and impacting the monarch migration in a negative way. So some of these are factors that have impact and broad implications for insects in general. Some are very specific to the monarch migration itself. So the higher heat, we don't need to go into documenting the higher heat. Everybody who's here knows this. But because these are cold-blooded insects, they have higher caloric needs when the temperature rises. And at that same time, those higher temperatures cause nectar to be less abundant and of lower quality. Also, just generally heat stress on the butterfly, like all organisms, once those temperatures are so high, they weren't really built for that. And so there's a lot of problems there. We've got the impacts of drought in terms of dehydration, and also killing out the nectar sources that they rely on, which are particularly important for monarch migration because they will actually not feed all winter long. And so when they're in this migration, they are going to need to gain weight during their migratory period, and then they'll live off those fat reserves all winter long. So if they're not finding their nectar sources, not only is that a short-term impact, but it's a long-term impact on impacting the migration as well. And then obviously higher CO2 is fueling invasive woody vegetation, which is destroying grasslands as well. Now, things that are very specific with climate change that are stressors in the migration is at higher temperatures, the monarchs are going to break what they call reproductive diapause. When monarchs are in the migratory, the fourth generation that is born is going to go into what's called reproductive diapause. They won't mate or lay eggs. They will be about 20% larger than the previous generations of monarchs during the summer cycle, and this is so to enable them to fly those great distances and then to live over the winter in their overwintering grounds, and then be able to survive to the spring and then make it back up to Oklahoma and Texas. Unfortunately, as these temperatures are getting so much higher, they are literally breaking diapause. And so instead of thinking about migrating, and they're thinking about mating, laying eggs, and staying where they are. In the same thing with the disruption to the migration timing, they're going north too early and they're staying there too long. So it is disruptive in all sorts of ways, and we see that with let me see if I can get my slide's not advancing. Hang on one second here. Okay, we may have to just do talking. Why is my slides not going? Give me 1 second here. Okay, let's go back in that. Sorry about this. Here we go. Okay, so we can see that with the numbers, these are the overwintering numbers at the monarch overwintering sites, and as you can see, they are in steep decline, and they are in fact they've been warranted as Fish and Wildlife Service says they warrant endangered species protection because the numbers are so disastrous. So when the numbers hit their all-time record lowest, winter of 2013, 2014, the USDA released the priority zones of where we were going to have to do work if we were going to save this monarch migration. And the priority, was, Oklahoma was right in the middle of that territory. And unfortunately, Oklahoma's lost 96% of its native grasslands. We have the most degraded habitat anywhere along the flyway. We're critical for both the returning migrants in the spring and to find milkweed and to continue to further the migration in the spring. And also when the migrants are turning back in the fall, they have to be able to find those nectar resources in a huge way in Oklahoma to make sure that they can live through the winter. So, so at that time, not much was being done, 2013, 2014, in Oklahoma towards trying to save monarch butterflies. But because we've got 39 federally recognized tribes, we had 7 tribes that stepped in to form a coalition to do something about this and formed Tribal Environmental Action for Monarchs. So 7 tribes initially restored 350 acres, 50,000 native milkweed plugs were planted, 30,000 native nectar wildflowers were produced, and a seed bank with 154 native plant species was created to support them. This was all based on a habitat island concept to go through in degraded landscapes and replant dense plantings of native milkweeds and native nectar wildflowers. This effort, which is still the largest boots in the ground monarch habitat restoration effort ever implemented in Oklahoma, gave way to a much larger organization called Tribal Alliance for Pollinators that is seeking to help all of our, not just our monarchs, but all of our pollinators that are being so badly impacted by climate change, by habitat loss, by too much pesticide, too much herbicide. It's real. Those numbers are down, and there's catastrophic consequences if we don't do something about it. We've got almost, I think, 89% of plants on terrestrial Earth require pollinators to continue their life cycle, and a third of all agricultural crops require pollinators. Monarchs are a great pollinators, so are native bees. Need to do what we can to help them. So climate change is there. It's one of the many stressors. It's unfortunate, I think the hardest one in some ways for us to do anything about, but something that the founder of Monarch Watch and the co-founder of the Tribal Environmental Action for Monarchs used to talk about. It's like, if I was a little butterfly, where would I find something to eat? So it's not going to be there. It's not going to be there. It's not going to be there. So we need to get these grasslands restored with particularly as climate change accelerates. This is the one variable that we can all be doing something about, and it does not have to be difficult. So, hopefully this beautiful icon and majestic symbol of everything that's good and right with the world continues on for more generations. But it's in the face of everything that's going on, it comes down to us. So we're here, Tribal Alliance for Pollinators, to help you, help your people, help your lands, and please feel free to reach out with us.
Wow. Thank you so much. This was so great. I'm just blown away by everything that was shared by all 3 of our presenters. And I know that this is just a tidbit of all the great work that you all are doing. I think we could all sit and listen to longer presentations from each of you. So really appreciate you sharing all of that. We have time for questions. So I'm going to encourage, if you're in the audience and you have a question for our presenters, please put them in the Q&A function and we will go through those, or feel free to raise your hand.